From my side, welcome to my extended talk of the SignalStore. Let's put it like this. We have quite a lot of time available. And yeah, I have done this talk already several times, but this is now the first time that I do the extended version of it. And I hope that it's worth it. So Alain already introduced me. My name is Hahnekamp. I come from Austria, part of NgRx, and since late also part of the NgRx team as trusted collaborator. And I'm also a GD. So the way how I want to do it is that there will be not so many slides. Most of it will be live coding. I have some branches if I make some mistakes, so everything is secured. But you see the chapters that we have. And I plan that after each chapter, because we have 90 minutes left, that I will make a small Q&A session, so a small break where you can ask any questions that you have, and then we'll just continue with the next one. So we'll first start with an application walkthrough so that you understand what this application is actually doing. And in its core, the complete exercise that I will be doing is a refactoring towards the SignalStore. So I have here this quiz application or this quiz component that I will refactor. And I will do it 2 times because very often when it comes to state management, developers always say, why do I actually have to use a third-party library? Why can I not use it on my own? So we had this already before with the global store, where very often I heard, why do I have to use, for example, the NgRx global store? I can just go with a simple service and use a behavior subject. In the end, this is the core essence of the global store, and I can build it on my own without having that dependency. So what I will do first, I will really try to build my own, not full state management, but I will try to come up with a service that contains a signal which acts as the state management thing in that case. And then once we have it, I will create the same service again, but by using the SignalStore. And by doing that, I hope that you see the difference and that you also understand the advantage that you get when you're using the SignalStore and don't just go with the native service. So this is the service state management basics chapter. Then we have embedded RxJS. So this is a very special function which we have there. And then, of course, the most powerful feature that the SignalStore provides, which are the extensions. And if some time is left, then also the Q&A. Good. Then we start with the application walkthrough. So this is my application that I have here. As I said, it's not the first time I'm doing this, so you might have already seen this application. It's a quiz for different countries, for different cities. So in my case, I take here the city where I'm living currently, which is Vienna. And you get here some different questions asked. And then you can say, yeah, what's the population? Well, it is around almost 2 million. So if you click on the right answer, it turns green. If you click on the wrong one, it turns red. And as you can see here, we have here a status box, so to say, which shows me how many questions have been answered correctly and incorrectly. And then here at the very top, we have here something like a countdown. So I have only a limited amount of time left to do that quiz. And I mean, that's it. That's not so much. And for the implementation, I have used here just one component in the beginning. It's 3 components. It's a container component. So we have here the quiz component, which is doing all the logic. So you see here, there is quite a lot of TypeScript there. We'll go through it afterwards. And when it comes to the template itself, the quiz component has delegated the rendering part or the real UI part to UI components. And there are 2. One is the app quiz status component that is showing the countdown and the status. And then we have one that is representing a question. So all of these components, they are single file components, as you see here. So not this analog format, but it's still in the normal Angular. But I always say, if I have just a bunch of lines of template, then maybe I don't think that I have to create an own HTML file. But yeah, that's more or less like a question of personal taste, I would say. But yeah, in this case is the status component. you see I'm already using the latest API. So I don't have here any input decorators anymore. I'm getting already the time left and the status properties directly via the input function. And in this case, it's also a signal. And then I also have my quiz question component. In this case, so this application here is running on 18.1. That's why we also have here the let syntax already available. It's highlighted here as an error because I didn't update IntelliJ. The update was released yesterday, and I didn't want to update when I give this talk today. So, but it still works. So if we click here on the compilation, of course, although the IDE doesn't understand the let syntax, the Angular compiler does, and so it's perfectly fine. What I also did, and this is something I want to highlight, I also created already a test because I said I will do huge refactoring. And there it's also always good if we have a test available that tells us if the refactoring actually was successful. I will then, of course, provide you with the sources here, but you see that this is not a non-trivial test. I would say it has quite a lot of in it. This is actually something which I would call integration test. So when I'm doing a refactoring, I have to come up with a test which is not coupled too much to the implementation, because what I don't want to do is that I also have to refactor my test. So what I have here is that I say, I don't really want to go too much deep into the things. I just want to boot up the quiz component. I know that there will be some HTTP communication, that something of it will happen. I will mock that part here by using the testing controller. And then everything else I'm going to do is that I say, I just want to click on some answers. I want to click on the right answer first and then a wrong answer. I want to see that the status message shows the correct information. If that works, then I'm already on the safe side. And then I have a last test, which says I also want to verify that the countdown is working correctly, meaning in this case, I have a mocked quiz, which ends after 2 seconds. So here I say, after 2 seconds, there must be a message that tells me now the time is up. And as long as these 3 tests are working correctly, I know that my refactoring was also successful. And again, the goal is that I don't have to touch my tests anymore. They stay as they are. So very high level test in that case. Good. So then let's take a look to the quiz component where we have all the logic. So I have already here made some comments that we kind of bring in some structure. So what I have here is a signal of type quiz. And we can also see that this is the state already. So I say here, I have one huge signal where I want to put in those values which are necessary for my component or for my use case. And whenever we do this, whenever we have a signal that contains a little bit more than just one value, then it's very likely that we already have the need for some kind of state management. Let's put it like this. Because what we always require are some kind of slices. Yeah? So here I say, well, I have my quiz. It comes with questions, which will then be loaded, of course, then also time in seconds. But in the end, I say I have presentational, I have UI components, and those components, unless like the quiz component, they are not interested in the complete value. They only want to have partials of the signals value. And that's why I always have to manually create those kind of slices, where I just have a computed that goes into the signal and says, yeah, I want to just fetch out here this kind of partial state. Then I also have here this time started. This is not really a slice. That's just a normal signal. And then we also have derived values. So next to slices, which we generate by computed, we have something else we generate by computed, but these are then really derived values. And the status is obviously one of them. So every question has a property, which is called the status property, where it stores if the question has already been answered and if it was correct or incorrect. And this computed goes through all those questions, aggregates, sums up incorrect and correct answers, and then produces this status signal here. And then we also have logic. So this is also something which we always have. We have derived values, we have slices, and we have logic. So this is something which we which you have to expect. In my case, we have three kind of logical parts. The first one is the loading of the quiz store itself, of the quiz data itself. So you see the way how I do it. The way how the quiz or how the quiz ID comes into the component is via property binding. So we have here again this ID with input required, but it comes directly from the route. So in my route, there is a quiz and then slash and then number one, number two, whatever. And the router is doing then for me internally property binding. And of course, I have to react to this kind of value here. And that's why, and that's the only way how I can do it. If the basic type here is a signal, I have to use an effect. Now I can use an effect in the constructor, or I do it like I do it here. So I can assign the outcome of an effect into a variable. This is something which is perfectly fine. My opinion, I really like it because it forces me to provide a name for the effect so that I know what this effect is actually doing. So in my case, it's loading here. And then we have here this typical explicit tracking, where first of all, I say, I want to define those signals that I want to track. So those signals, whenever their value change, for those that I want to rerun this effect function. In my case, it's just the ID. Yeah, and then I have my untracked, where I say, okay, and now I'm going to call maybe some dependencies. I'm passing on, then in this case here, this ID. And I don't want that whenever in one of these dependencies, some other signals are used, that they are then also automatically tracked here. This is not what I want. I only want that the effect runs when the ID changes. And that's why I put everything else into the untracked function. So that's what we call explicit tracking. Then this is the first part of the logic. The second one, that's very simple. So we have here an interval that represents the countdown. So with every second, I am reducing the time by 1. And then we have here the answer. So whenever I, as an end user, I click on an answer, then I'm calling here this event handler. And yeah, so I'm getting here the answer ID. In this case, it's called the choice ID. So I'm going through the questions. I check if my answer was the correct one. And then I'm updating my question in the quiz signal. And what you see here is this typical update statement that we have with every signal. We always need to do an immutable update. So in this case, I say when I need to override a question, in this case, when the question ID matches, I need to clone the existing question, and I'm going to replace the status with the new value. And at the very end, I'm also cloning the complete value of the state and then returning a completely new object reference. That is necessary because otherwise compute and effect will not be notified by that particular change. And this was the application walkthrough. And the next thing now would be to migrate or to extract the logic here to a service, kind of making my own state management. But before I continue, as I said, if there are some questions in the meantime, I would now be happy to answer them. Let me quickly check. Hi, I'm an AI assistant. Okay, good. Very nice. Just curious, will be recorded on YouTube later. Yeah. Okay, looks like we don't have any questions. Then let's move straight forward to the refactoring part. So what I'm going to do is that I say, well, I need to come up now with a service. This is where I want to put my logic. So I say here I have a new file, and I say, well, quiz store TS. That's an Angular service, so a simple one. So I say I call it quiz store. We can provide it in root if we want to, but we can also do local providing, which is also something which we see quite often when it comes to local state management. In my case, I leave it as provided in root. So what the quiz store is now doing is that it manages the state for me. So that means I need to go back to my component, and now I need to kind of copy and paste a lot of code and do a little bit of updates. So I say, well, the state is this already. It's the quiz state, and I can already also copy the slices and the time started, time left. So I'm just going to take all of it, and I'm going to copy it in here. In a service, we don't need protected. Everything is public in this case that we want to expose. And what we don't want to do is that we want to expose the actual signal, the writable signal. This is something that we want to keep in the service, which means that the component cannot update the state anymore. And because of that, of course, our service then needs to provide some kind of methods where internally the service can then update my state. So that's why I say immediately it's not protected, but it's private. So quiz state now is private, only available within the quiz store. By the way, if you don't know this hash notation that stands for ECMAScript private, which means it's not just private for TypeScript, but it's also private during the runtime. So if somebody would say as any and then access quiz state, it will not be possible, also not during the runtime. Good. So this one is then exposed. So we see we have still our slices. They will not go away. And if I go back to my components, I can then remove all of it, because the only thing that I'm now going to inject is the new quiz service, the quiz store, sorry. So I say here protected read-only, quiz store, inject quiz store. Why do I do it like this? Well, because the quiz store in this case is really made for local state management. So it knows quite a lot about the way how the signals are meant to be used. Could also say it knows a little bit about the view model. So what I'm going to do here is that I'm going to allow the template to access the quiz store directly. If it would be a very generic service, which can be used in multiple components, I would be a little bit more hesitant there. But since it's a service made for the quiz component, yeah, it's perfectly fine. So I would say here and here and here, that here we are going to access our quiz store. And you see that's perfectly fine. No error message in the template. So this was the first part, extracting the slices. The next one is then, of course, extracting the derived values. It's the same exercise as before. So I'm going to copy it. I'm going into my service. I'm going to paste it, remove the protected, and then I just have to check if there is something that I have to update there. No, because these questions also does exist inside of the service. Derived values are done. Of course, since it's not available here anymore, the status, I also have to access it here. Good. And then comes the logic part. And I will start with the easiest one, which is the answer. So I say, okay, my service then needs to provide an answer, because this is now a logic part that will directly manipulate the state. And that's only what the service can do. So I'm going to copy it, put it here, maybe also say here logic part. See here, well, this is my service, the answer. What do I have to do? Well, in this case now I have to update the state directly. So that's why I have to say here, yeah, I'm going to update it. Just use the right variable name, and I'm done. Again, template, have to say here quiz store answer, directly call also the event listener from the store itself. And then, it starts to become a little bit complicated. That's still easy, I would say, starting with an interval. So we also have a constructor in the service. So I can just also copy this one and put it here directly into the service. Why not? Careful a little bit. In my case, the quiz store, of course, is now provided in root. So it's running now globally, which is not optimal if we have a take until destroyed, because the countdown will continue to run even if the quiz component is closed. Yeah, so I mean, maybe you would in real life, you would remove here the provided in root, make it locally providing, then it would be fine. But in my case, yeah, let's just see if we can get away with that part. Also moved, and then comes the last part with the untracked, with the loading. That, of course, is something which I can't just copy anymore, because the ID is now part of the component. This is coming from the router. I cannot delegate it to the service. So what I have to do instead is that I have to create now in my service a load method, which will be called by the effect. So the effect is still part of the component, but the loading, what we have here, these two lines, they are now extracted into a method of the service. So I say, okay, we have also here a load method where I say, yeah, you need to give me a number of the quiz ID, and then can also be an async one. And then I'm going to access the quiz service, which I still don't have. So let me quickly add that one. Quiz service, inject quiz service, and yeah, also read only. And then where are we here? And we set the quiz state once we have the value available. So in this case, it's the quiz ID. That's now the load method. And now I need to go back into my component. There I have to say, well, still in the untracked. So this is still task of the component because the component is doing the effect. So that's why it also has to make sure that explicit tracking does not happen. And here the component then just says, okay, quiz store, please load now my ID that I have right here. I don't need the quiz service anymore. That's now also handled by my quiz service. The async is also not necessary, although we are returning here a promise. It doesn't matter. The load effect is just a fire and forget. It will load the quiz and eventually the data will be available. And then the quiz store with its computed, with its sliced, will notify our template and it will then hopefully be updated. So let's quickly check. The application is still running. Here we have executed 3 of 8 success. So the tests are also working. Last check. I go into my browser and just verify it once with my own eyes. Yeah, looks all good. Yeah, so this is what we usually can do. Just using the signal as the main container to store a state. That's also why we actually have a signal for. Of course, hide the signal from the components, use it only in the services, and then the service needs to provide ways or methods where the signals will be internally updated, and of course also the slices which our presentational components require. And I have done this without any usage of any state management library or anything else. That's just pure Angular what we have here. Good. That was the second chapter. Let's check if there have been now questions asked. Nope. Did I understand that? There is one question. Did I understand it right? The hash is more private than private. Is there something instead of protected to? No. So as far as I know, protected is TypeScript only, but the hash has been introduced also in ECMAScript, also in JavaScript natively. And if you want to have a full safe private in that sense, then you can use the hash. Careful, there are some potential performance considerations if you use the hash, because it could be that the TypeScript compiler needs to come up with a polyfill or a shim, or it can't use the native hash because for some reasons it needs to support a browser that does not support that ECMAScript version at the moment. In those cases, you still have some kind of private during the runtime, but you might have some performance risks. Let's put it like this. If you want to know more, there is a very good article from Mathieu Riegler. I think it's one of his latest, where he explains also, especially in Angular, how you can kind of do the right configuration that when you use the hash syntax that you don't run into performance issues. Do you prefer constructor effects or named effects? I would say if I have just, by the way, if I have just one effect, then I would just put it in the constructor. So in my case, I would not complain if the effect would also be in the constructor. But if you have multiple effects, then I really want to maybe quickly be able to identify what this effect is doing. And that's why I always put it outside and out of the constructor so that I have to assign it to a variable name. That's my reason. If the data is loaded through a resolver and given to the component through an input, is it okay to just forward it to the state store via a method like the ID in your case? Yes, you can do it like this, but in my opinion, I'm not using the resolve pattern so often if I already use state management, because then state management is the one that is loading the data. And I don't want to kind of do it one time where the resolve and then another time with state management. So I really then try to stick to state management and not to mix it. But theoretically and technically, yes, you're right. That also works, of course. Okay. Good. Then we'll continue with the SignalStore. So what we have now, application walkthrough is done. And now we are at the basics. So what we are going to do now is that I'm going to introduce the first part of the SignalStore. And there is a reason why I did the service before. You should see that the SignalStore is doing nothing else than in a way constructing the same service that I have done manually, but it just tries to help you in various ways that you are faster doing it. This is the first part. And it also gives you some kind of structure. So it forces you to not to mix things, but you have in certain places where you have to put your slices, your methods and all that stuff. And then later, we'll also see more of the advanced features of the SignalStore where we have to say, yeah, if I want to do this manually, then I would have a hard time doing it. And then we see really where the power of the SignalStore comes from. But in the beginning, you can say it's a bunch of utility functions that help you to construct a simple service. That's something which is a valid statement for the beginning, I would say. So I'm going to rename this service here because I will leave it that we might see the difference so that we have some kind of comparison from time to time. So this is now the quiz with 2S. I will also then create a new quiz component TS. I'm going to copy everything that I had here, right here. So we have here our old quiz component. And by the way, I think it's obvious, I didn't mention it before, but you see that this is now a very, very fine, smart component we have here. Not that much of logic, very clear, very readable as we want it. And for the quiz component, I will set it back to its original state because from now on, the quiz component will be powered by my SignalStore. Sorry. By the way, I'm already using the latest version. So I'm already using the release version of the SignalStore, which comes with some tiny but very useful features. So if you remember, before I started to copy the state and the slices to my service. And this is how I will start now as well. So I have here my quiz and I say again, yeah, and now I have another quiz store. But I don't create now a class. With the SignalStore, you will almost never see a class anymore. It's only about functions. There is this nice joke that everybody is kind of discussing in the community if we should go with functional components and so on and so forth. And the SignalStore has it already all the time. So the SignalStore only consists of functions. And I will explain later why that is the case. So I say the first function is SignalStore. Yeah. And I can now say, okay, I want to define the state that it should manage. So I say here with state. It's another function. So we have already two functions. And what this with state wants from me is that it says, well, you need to give me now the initial state. And if you remember, in our component, the state was here, this signal here, this quiz. So I'm going to copy it again, put it here. And there is something I have to do here because the state in our case is using type inference. And the problem always when you have an empty array is that TypeScript cannot guess the right type. So in this case here, it says never. So that's why I say here new array, or use some other syntax. So I say here that's a new array of question. It's an empty array, but now this is very type safe. You could also use your generics methods if you want to. I did it here with the array. This SignalStore function with the with state is already generating me the service. I can now also define if I want to provide this service globally or if it should be locally provided. And I will do it in the same way as I have done it with my other service before. I'm going to say this is a global service. So I could say here, the first parameter is always something which we call the configuration. At the moment, there are just two configuration values available. One is provided in root. The other one is where you can open up the state so that it can also be updated outside from the SignalStore, which is something that is disabled by default, starting with the release. So before the release, everybody could very easily update the state from the outside. So every component could update the state. And now with the release, you have to explicitly enable it. So just to show it quickly, you would have to say protected state is false. Then the component could also update. But yes, as you have seen before, in our service, the state is private and we want to keep it private. So I'm not even go into and say here protected for state will be false. SignalStore is internally creating a class, something we don't see that often in Angular, that a function is generating a completely new class, but with the SignalStore, that's the case. So I need to say here, I'm going to export a quiz store, and you see here, I'm here using the capitalized form on purpose, because this is an instance, this is a class. Good. If I do that, then I can immediately jump back to my quiz component, and I can now do here the same thing that I've done before with my other service. I could say, yeah, it's a protected read-only. Again, my template will get access to the quiz store. And I say inject quiz store. And I can remove now all the state and the slices. Because what I didn't say before, the slices are now already included. So they come more or less already out of the box. So if I, for example, go down here to my template and say, well, I didn't manually create the computed for my title, I don't have to do it. It's already there. So if I say here quiz store, what do you have? It says, well, I know what you have in your state. You have title, you have questions, you have time in seconds loaded. And I know that slices are always necessary. So I'm just going to create it for you. In my case, I say, okay, then I'm using the title slice automatically. There is also the slice for the questions available. And if there would be something else, status is something which we have to come up then, it will also be available. Good. Of course, things are now going to fall apart here because this is something which we still have to copy. But if we compare it, if we would now say, well, the quiz store compared to our quiz service that we had before, where is it? Quiz. Here we have it. So these few lines here, they represent all of that. So we see already quite a little bit of an improvement. It will not stay like this. So we will then see with the methods that we add, we will end up in the same amount lines of code, but nevertheless, if it comes to scalability, it's a very small state here, then again, the SignalStore will end up, will give you also fewer lines of code in the end. Good. So this is what we have done now. We have now slices and the state available. A state, again, it's private. That one's protected. Nobody can access it from the outside. The next thing would be the derived values. So here the status that we have here. And this is now the time where it is important to understand the second advantage of the SignalStore, namely that it enforces this structure. The SignalStore says, well, you can with the service, you can kind of mix things up. You can start with slices, then maybe comes a computed, then comes another slices, then a method, and then another slice. Not so with the SignalStore. With the SignalStore, every piece or every type has its place. The state has a place, as we see here with state. And the same is true for the logic and for the derived values. And the derived values, they are generated with another with function, and that with function is then called with computed. So what is with computed? With computed expects from me a function, and that function will get not the store, but the state. Yeah. So the SignalStore gives me in this function already access to the slices. That's more precise. It's not the state. I only have here access to the slices. And it expects from me now that I'm returning an object literal which contains computed properties. That's it. And only that. So I have to say here status, and I can copy it from here as well, because in the end it's the same. So I say here status, that comes via computed. Our computed, of course, wants to access, in this case here, the questions slice. But for that, I don't have a this here. I have a state. So this is why we have here the state already available. And if we do that, then we have here this kind of place where we have to put all our other derived values. And we can't put anything else here inside of it. So I could, for example, not say, well, what if I say here, I'm going to generate here a foobar or something like this. So a method which is returning return bar or something like this. That is not allowed, because with compute, it says, hey, you are supposed to return me an object literal which has only values of signals. So it really also tries to enforce it as much as it can. And with computed, the status property is, of course, not immediately available as well. So if I now go back to my quiz component here on the left side, and if I scroll now, if I go now to my app quiz here, then I say, yeah, the status before was a problem. I mean, I also have to remove it from here, because now it should only be available. It should now only be provided via my quiz store. Yeah, so I say here, okay, quiz store, add it here. And you see, or you have seen, the status is immediately available. So it was just added. In a way, you can also see, I mean, you see already a little bit here how it works with the SignalStore. You have a bunch of functions that you add up. And in a way, it kind of works like a modularization pipe. In German, we have a very special name for these kind of things. I looked it up in English. There obviously is not a real term for that. But in German, we would say Bausteinprinzip. Yeah, either way, you just build up your SignalStore step by step by adding one function after the other. And then, once we have the derived, we also need to come up with the logic. So, and the logic also comes with another with function. And in this case, I say with methods. How does this work? Very similar to the with computed. But I don't just get the state here. I'm getting the complete store. What's the difference between store and state? Well, the store could also contain already methods, logic methods, that I could reuse here in my with methods. The with computed is not allowed to have access to any methods, because it shouldn't run any logic. So there's a reason why I name it here store and not state again. Yeah, but in the end, I still have to return here an object literal, which contains the methods that should be added to that service, because in the end, it's still a service. Before I do that, maybe a few words. Why functions? Why does it look like that? The SignalStore has a huge focus when it comes to tree shakeability. So it doesn't want to kind of extend your JavaScript bundle size too much. And the problem is that classes are not that good when it comes to tree shaking. If you would have here a class, and the class would have those methods with computed with methods, and you might not use, or let's just say the class has 10 different methods, and you only use 5 of them, then all of the 10 will end up in the JavaScript bundle because they are methods, and methods can't be tree-shaked. Here we have functions, the standalone functions in that sense. And here the tree-shaking mechanism is really efficient. It says, yeah, maybe there are 5 different other SignalStore functions. If you don't use them, I will not add them to the JavaScript bundle in the end. So this is very good. And it's not just about these feature functions which we have here. There are also some other helper functions. The SignalStore only uses function because of this tree shakeability. There are also some other reasons when it comes to extensibility, but one main aspect is definitely the small footprint that you get when you use the SignalStore. So back to the logic, to the with methods. We'll start again with the very easy one, which is the answer function. So I'm going back to my quiz store service. Here we have the answer. I'm going to copy that, and I say, okay, it's just another method in this case, which says, okay, I need to access here questions again. And I say, yeah, these questions don't exist, but we know already how it works. I just access here store questions. Good. So far, so good, but we are not done yet. There are some problems now. Because before in our service, we had direct access to the state, not here in the SignalStore. We don't have direct access to the state. So we can't just say, I don't know, store update or something like this. There is no state. Instead of that, what we have is a function which is called patch state. Again, a function, not a method. And what patch state does is that it can internally update the state. And not just that, there is also a reason why it's called patch state. It also helps you or makes it easier when it comes to immutable changes. Because the patch state says, regardless what you usually have to do with update and with stat of the normal signal, where you always need to do cloning and all that stuff, not so with patch state. You just provide me those properties that you want to have changed. I will do that for you in an immutable way, and I leave the rest as it was. So in my case, that's quite helpful because I say I only want to update the questions, and I don't even know what else might be there in this signal. It's just about the questions, and this is exactly what we can do with the patch state. So I just say patch state like this. I provide my state, so patch state does not have a binding to a state. We need to do it like this, store, sorry. And then I say, yeah, I only want to update the questions and nothing else. So I just say here questions. That's of course also type safe. The patch state knows because it knows what the store is. It knows about the type of the state. Then I can say, okay, this is my map where I'm going to reconstruct my questions. We know what we have to do in order to get access to them, namely this. And this is something, this whole function with the spread operator here, I don't need to do this anymore. I just run the patch state. That's it. And the patch state can only be executed inside of the SignalStore. Again, this is something with the release. Former versions, you could also run it in a component. But now with the release, you can only run it actually here in the with methods and nowhere else. So it's also safe. You know there is just one place where the state gets updated. Very good. All right. Loading can be done very easily. Yeah, we just say here again, yeah, wonderful. Let me put it here. It's in this case, it's an async method. Yeah, and now we have the quiz service, which we need to inject. How do we do that now? There are now different ways. There are actually 2 ways on how we can access the dependency injection. One way is that we say, okay, we create here a return, and then we say here quiz service inject, because the inject function is available here. So there is this kind of space before we are returning something where dependency injection is active. But you can also do it in another way. You can also keep it as it was before. And you can do something like this. You can say, okay, this is a function with methods, and the quiz service is provided here as an argument. Obviously, it isn't, because the SignalStore cannot guess what you want to have here. But what we can do here instead is that we can provide a default value. And I could say here also inject quiz service. This is something, this kind of style is something which you very often will see in the documentation. That's why I also use it here. I would say it depends. If you have a lot of services you want to inject, then probably not via parameters. You want to put it into the function. If it's just one, yeah, you can also keep it like this. Either way, we end up with having access to the dependency injection and thus also access to the quiz service. So I say here, okay, quiz service find by ID. And then we have our set method of the signal, which does not exist. No problem. We just say patch state. We say, well, we want to update the store. And in this case, we want to update the complete state. So I'm not providing here a partial state. I just say, take everything from the quiz. It contains everything that you require. And then we have the load method available. By the way, if I go back to the quiz component, just take a quick look how it looks at the moment. So if I say here this quiz store, then we see the slices, the derived values, but also the methods are already there. Good. We are almost done. There is just one method which is left, and that's the, oh, we have the load, we have the answer, we have the interval. The interval is missing. What we have here in the constructor. Yeah, so how do we do that? We will first of all make it simple, and then we will learn about a very powerful function called Rx method, where we can do it in a very nice, elegant way. But now, brute force, very simple. A constructor. There is no constructor. We don't have a class. Nevertheless, we need to find a way how we can start certain side effects like the interval in the very beginning. And for that, surprise, surprise, there is another function which is called with hooks. So with hooks, I can define things that should happen when the SignalStore gets instantiated and when it gets destroyed. And as with the other methods, I also get here access to the store. Store, not state, so I also have here access to my methods if I want to. I now need to register my hooks, and I say, well, I'm only interested in the onInit hook, not in the onDestroy hook, which in this case almost works like the constructor. Not just almost, it is actually like the constructor, because if you remember, or if you might know, the onInit, the injection context is not available, but in the onInit, it is. So I can also use it a tick until destroyed, which requires an active injection context, which means I can copy the whole interval here. I say, okay, start it. And then we have here our time left sets and time seconds, which comes from my service before. Let me quickly extend my state. So we say we have here time left, which is a number, hopefully. Just let's say 180. And time started, which is new date. And these two properties are now required here in this hook. So what do we have here? We have a subscription, and then we are updating our state. So I say here patch state, because that update will not work. What I want to update? Well, the time left should be updated. And for that, I need to copy now that part here, times left. Always careful with this copy and pasting. Many things can go very quickly wrong there. So I say here store time in seconds, of course, also available immediately as a slice. Same goes for time started. Then I can remove it. Yeah, and that looks correct. Yeah, so now we are starting here already the interval as well. And I think we are done with the basic structure. So again, SignalStore, one place for the state, one place for the derived values, one place for the logic, load, answer, and then here the hooks, which in a way are this kind of instantiation commands or however you want to call them. Again, careful here. We have the same problem here what we had before. This interval will run even if the component is destroyed, which is not very optimal. Yeah, but let's leave it like this. Let's go back to our quiz component. And now let's make here the final touches that we can really use the quiz store, which means I can, again, remove quite a lot. So I can remove constructor, the answer, all of that can go away. The time started, the time left as well. The quiz service as well. We have only the quiz store. And here in our untracked, which is to the same thing we have done before, we say quiz store, and I'm calling the load method. And I say, yeah, just use the ID that we have. I'm saving it. The test reruns. Yeah, we will see. Here is still a problem. Yes, of course. Quiz store. Not that fast. Does it compile now? Yeah, maybe it's always better to check first if it compiles and then check for the tests. Seems to has that it has lost its connection. 1, 2, 3. Yeah, test run through. Wonderful. Everything seems to be working. And here again. Okay. This was the major part. So I think I don't need to repeat it. We have now seen the patch state and the structuring mechanism. That's the basic stuff. And after the questions which have been asked, I guess, we can take a look at the advanced stuff where we see, well, this is why we really want to use the SignalStore, not just because it's a bunch of functions to construct a service, which we can very easily do manually. Good. So questions. Do you prefer if the data? If a computed needed a computed, would you restructure with computed to have an inner return block on and use some computed const above the return? I would do it via the scope. So what you can do, and this is the same with methods. If you need to reuse an existing method in with methods, then you could theoretically come up with 2 with methods, or you can say, in this kind of function that you're returning, before you return this object literal, you're creating, in this case, a new computed, assign it to a variable, then you are exporting this variable, and at the same time, another computed can now access your computed. I would do it like this, but I'd say, again, that's more a personal taste question. Where are the data available? Where are data available in state in with computed coming from? Yeah, that's available because, so here the state, because the SignalStore understands what you have done before. So the SignalStore says, okay, with computed, I'm going to check. Oh, sorry, I need to share my screen. So the SignalStore in this case, the question was, why does the state has all these properties? Because I have defined it here before. So everything that you defined before of a particular with computed or with methods is available to the following one. Which also means if I would say here, well, the with computed comes before the with state, and then we have a problem. Because then nothing compiles here because, yeah, it's at that point in time, the state is not available. So this is this kind of adding features step by step, incrementally. So the order, to make it short, is definitely important when it comes to the SignalStore. I think you should use to start loading some data as soon as the component starts. Well, this is what the effect is already doing. So if you remember, the effect is waiting for the ID, and then it starts with the first run of the effect. Effect runs always in the first time. It starts to load quite quickly. Which cases would fit to use with hooks beside the timer? I like putting side effects from an Rx subscriber or signal effect in there. Yeah, in general, any side effects which you think they need to start running right now, this is then on init, and everything else when you have something which you need to remove or something to clean up, that usually ends up in the on destroy. When would you say that using store would be the best way of implementing even for smaller projects? Looks so much cleaner. Honestly speaking, yes. So, I mean, you said it right. You can, by the way, you can also use the signal state. That's a function which is in its sense only signal store with state together. But in the end, whenever you would create a service, you see it's not really a big deal if you already have the NgRx signals installed just to go with the signal store. And in general, I like it if everything is always following a straight structure. So when we are using the signal store, then we are trying to use it as often as possible. So I really like that. Is take until destroyed an RxJS function? It's an RxJS operator coming from Angular. Has been introduced in Angular 16. And what it does is that it waits when the component or when the service is destroyed, and then it does an automatic unsubscription. Good. William has already answered that. Then is it a problem to have many different stores? I have an app where a user can manage their profile. So they have the page to manage its position, bookstore, photo store. So in general, no, definitely not. So there is not a problem at all if you have many stores. I would even expect that you have a lot of stores and not just one. Using lightweight store management like SignalStore, the use of facade becomes unnecessary, correct? Yes, correct. So facade was something we used before, for example, for the global store, where we wanted to hide the action and the selectors from our components. So the NgRx specific elements. With the SignalStore, that's not the case, because the SignalStore is using a signal, which is an Angular element, and it doesn't create its own one. So it is already a facade in that case. Or other put, you don't need the facade anymore. So for smaller parts, SignalStore, but for global state, normal one. No, I wouldn't say that. Not so easily. It really depends. I mean, you will see the power of the SignalStore now, where it also becomes a candidate for global state management. The question for the global store really is if you need to use the Redux pattern. So if you have very complex use cases where you need this eventing, where you can say, I'm kind of dispatching an event, and then multiple feature stores, which are not aware of each other, which even know that they exist, they need React to it. And you want to have the read user, the effects and the actions. You really want to have that. Then the global store is something you can use. But if you start with a new project and you say, I don't need the Redux pattern, then I would also use the SignalStore for it. It's just to provide it in root, and then you have global state management. I mean, in fact, what I've done here is already global state management because it is provided in root. By the way, there is, since 2 days, there is now on the ngconf YouTube channel, there is the talk from Marko Stamenirovic available. He's the creator of the SignalStore. And at the very end of his talk, he also mentions this kind of questions. What should you do? And to make it short, he says, component store would now be succeeded by the SignalStore, global store. If you need Redux, yes. Otherwise, maybe you are happy with the SignalStore as well. Okay, half an hour left. Other dev tools for the SignalStore? Yes, they are available in the form of a community project, community extensions that we did. So just look up NgRx toolkit, and then you will find an extension. So it's just with DevTools that you need to add, and then you also have it in the Redux DevTools in the browser. Okay. Yeah. Then let's come to the Rx method. So what we have in our case, is, if we look at the component, well, let me quickly close all of it. Too many windows are opened. Quiz component. There we have it. We have here an effect. Yeah, we know what the effect is doing. I mentioned it before. It always runs first, which means the ID from the router will be passed on to my quiz store, and then the loading happens. If you're happy with it, we can leave it as it is. But if you would now say, wait a second, what if there are some race conditions? What if this ID changes quickly? And I need to make sure that maybe the loading in this case cancels its current request and only deals with the next one. So to put it in short, you want to use something like RxJS. You want to use an observable together with a switch map. That's not so easily available or possible. But what the SignalStore has, it provides you something what I always call an embedded RxJS optionality. So you can use RxJS in those places where you really need them without enforcing RxJS to everywhere else, but only in those places where you really need it. And in our case, we can do it with the load component, the quiz store load component. So let me quickly go into it. What we have, and this is now something that comes maybe step by step, or maybe not, let's not start with the load component. Let's do something else. Let's improve the interval, and then the loading will become easier. Or yeah, it does. Anyway, it will be a little bit more complicated. Let's say we have something which is called update time left. Now that's now another method. And what it does is that I'm doing here already in my hook here. So what it says, okay, whenever you call me, then what I'm going to do is that I say patch state store, I'm going to check the current time, and then I'm going to update the page. But you have to trigger me. So somebody needs to trigger me, and this is what our interval should be doing. Now, there is a very nice way on how we can now integrate RxJS into that, because the interval is already RxJS. The function here is called Rx method. So what is Rx method doing? Let me quickly rename it. And let's say we have another update time left, which will do the same thing, but in a little bit different way. It is generated by Rx method. So what is an Rx method? Rx method is a factory function. That means it generates you a function. It generates you a function with one parameter. You need to define the type of this parameter via the generic function like this one. So in this case, I say update time left. Well, although there usually is a parameter, I don't care what it is. So I just say it's unknown. But Rx method will create me now for my implementation, not to the outside, but for me, for the internal thing. It will give me an observable that will emit the value whenever update time left is called. And by doing that, when all the calls are now represented by observable emitting a value, I can control potential race conditions because I can apply pipe operators. It needs to take some time to get used to the syntax, but the way how we can access this observable is that we can't access. We just need to provide the pipe operators that we want to apply to that observable. So there is somewhere this hidden observable which emits whenever update time left is called. In my case, I just say there is not so much I want to do. So no race condition here really, but I have here my tab operator where I say whenever this internal observable emits a value, then I want to call patch state. Okay, so I can now remove this here. And to the outside, the update time left looks like a normal function. So if I am here in my onInit, and I say, my dear store, what do you have with this update time left? Then it says, well, you can provide me with any type you want, because during the construction, I said it's unknown. But this Rx method has now another advantage. I can also provide an reactive type, which means I could, for example, provide here an interval of type unknown in this case. So I could say here, I'm providing an interval, which means that my Rx method is now aware of it. Let me quickly close all of it. Is now aware that it has here an observable. Where are we? That we have here an observable, and it will then internally subscribe to this observable and apply the pipe operators on it. And of course, it will also do the unsubscription for us. So this take until destroy that I had used before, that's not necessary anymore. Rx method is doing all of that for me. So it's really like this kind of functions in the way of an observables. And now I also want to apply it to my loading method. And I do it in two steps. In the first one, where did my load go? Did I remove it? Yeah, I guess I removed it. Wonderful. Yeah, doesn't matter. We still have to re-implement it. Let me quickly check. Yeah, load has gone. Good. Load has gone, doesn't matter. Load, it's another Rx method. And I say, well, in this time, it's not an unknown. This time I need a number from you because it needs to be the ID. I need to do a request. And now I have again my pipe. Now I can manage race condition, because now I can say, I want to use a switch map, for example, meaning when I'm going to wait for a response for a current quiz ID, and the quiz ID changes, and I need to start a second request, and I want to cancel the first one. I don't need the response anymore. So this is where I require an observable, because the switch map is an RxJS operator. So switch map says, yeah, you get the parameter. The parameter is the ID. We see here it is type safe. The ID is of type number. And then I just say, okay, coming from my quiz service, find by ID and do it. I mean, quiz service find by ID would be better if that one would not now maybe not return a promise, but maybe an observable. That would make more sense. Let me quickly fix it, because otherwise the cancellation mechanism of the switch map would not really help us here. I mean, we can also provide here a promise in a switch map, but it's better in this case that it is an observable. This was the first step. I go back to my component and I check if the error has now gone away. It has. So we see here the load method. I can provide an ID, which is of type number. That's fine. Yeah, let me quickly check if the application is still running. There we are. Now it has crashed. Wonderful. Why did it crash? So I have stopped everything. Good. No, come on. Yeah, now we have an error coming from somewhere. Quiz, the get request is there. Patch state. Ah, yeah, of course I forgot the patch state. So it's fine if we have the quiz data. But of course, it also needs to do then something. So I have here a tab. I say, okay, once we have the quiz, we have to say patch state store quiz. Yeah, and now the quiz is there. If you know the error, it's always easy. That was the first step. Yeah, we are not done yet. The problem is, or the thing is, we can even make it easier. If you remember, I said before, the Rx method can also understand, can also consume reactive types. That's why we could provide a pass to that update time left an interval. That's an observable. What Rx method also understands is a signal. So what I could say, I want to provide the signal of the ID, so the signal that represents the ID to my load. And then again, Rx method understands that this is reactive. It will run internally an effect. It will track the signal internally and will map it to the internal observable. What does this mean? This means that I can now go to my constructor because now it goes without the effect. And I just need to connect the existing signal that I already have to my store. So I just say this quiz store load, and I don't say here this ID and call the ID. I just provide the signal as it is. And you see that this is not a type problem. It's not a compilation error because the Rx method says, although you said you want to have parameter type of number, it could also be an observable of number or a signal of number. All three versions are possible. And of course, this is now a huge improvement because now I don't need to kind of find ways on how I can bridge signal to observable and vice versa. I can just provide the signal as it is, and the Rx method will do the rest for me. So that's really great. And one last thing, and then we are done with it. Update time left. This is something which is an internal method, and I don't want to expose it. So I don't want that somewhere in my component, somebody comes to the idea and says, you know what, I'm going to update the time left on my own. Why wait for something? So I say here one or whatever. I said, no. This update time left is not meant for you. That's only meant for me. And since the release, there is now a convention where we can say everything, regardless if it is a method, if it is a state, if it is computed, as long as it has a prefix with an underscore, that's private, which means I can still access it here as long as I'm in my store. That's not an issue. But in my component, update time left has gone. It's not there anymore. So encapsulation is also there by convention by using the underscore prefix. That was the Rx method. Again, very powerful. We can add RxJS wherever we want, but in a non-intrusive way. That was the word I was looking for. I'm not going to answer the questions now. We will directly move on to the extensions because this is the last chapter. And then we will just do all the questions at the very end. Because we have 15 minutes left. I mean, I have more time left, but I don't know what other plans you might have. Extensions. As I said before, that's the most powerful feature. And I mean, personal story or a personal opinion of mine. Once we saw the SignalStore in the very beginning, we said, yeah, it looks like the component store. I'm not that happy with the component store because I want to use global store. But then we saw the extensions and what you can do with the extensions, what power it has. And I said, well, if the extensions are not available in the global store, then I would actually go directly to the SignalStore just because of the extensions. Not because of the signals. Component and the NgRx global store, they all have a select signal. So you always get the signal from them. But for me, for the SignalStore, it's really the extension that makes a difference. What could be an extension? Extensions are features that we can reuse, apply to multiple signal stores, and also customize them. Both is, we will do both in this case. I would say here, one potential extension is this kind of countdown. I would say, yeah, in the quiz store countdown is nice, but maybe this time left and time started and the update mechanism, this is something I also want to use somewhere else, in another signal store. How can I do that? It's extremely easy. We just need to take those things that we require and put it into a so-called SignalStore feature, which is a kind of signal store which cannot be used on its own. put it very simple. But we can apply with state, with computed, with methods. All of that is possible. So I say here with countdown, I have already created the file. And I say export function with countdown. And I say, you know what? You need to give me the time in seconds, because this is something that my store that uses me needs to provide me. And then I say, well, only those elements that I require, I'm going now to copy from my existing quiz store into with countdown. So I say from my with state, can remove this. I want to have time left, time started. This is what with countdown will provide. When it comes to the functions, to the methods, computed stays as it is, we have the update time left. I'm going to copy that one as well. So I say here, with methods, so store, like this. It's still, if it's also private here, I mean private to the components, not to the store that uses it. Time in seconds comes directly from the function from with countdown here on the very top. And time started should be there. So it's not interesting why it does not show up there. Yeah, because I've closed the so yeah. See if it's now better. Not really. Time to start Copilot. That one is usually very good in closing brackets. No, I should be able to do it on my own. Yeah, of course. I've missed one important thing. Return SignalStore feature. This is the container for all my features. I said this before, that there is a thing like this. And now it will hopefully work. Yeah, now it's much better. So the SignalStore feature is this mini SignalStore that needs to be applied to a real SignalStore. So we have with state, we have with methods, and of course, we also now need to expose the with hooks. So I'll just take all the with hooks that I have here already. I don't need them anymore, and I'm going to paste them right here. No. Good. Store update time left works wonderfully. Great. Why is it still compiling? It shouldn't compile anymore. Let's restart. Because all those countdown things, this time left and all that stuff is not available anymore. Did I copy it from the wrong one? Quiz components. Let's see. Quiz store. Oh. Then I need to remove it. So answer has been removed. Okay, of course, yeah. I left the state, that's why it was working. Yeah, now we are getting the errors, obviously, because we are not exposing time left anymore. But very easy to do now. We say, well, that's now all included in the with countdown. So everything that I need to do is that I say here with countdown. And of course, I need to provide here the time in seconds. So in this case, I say 180. We see the compilation is already working. And if I go back to my application, the countdown works like it was before. So you can very easily extract certain parts of your existing SignalStore, put it into a SignalStore feature, wrap a function around it, like with countdown, and then call this function in whatever SignalStore you want, and then you immediately have those features available. Those functions are also customizable. As we see here, we can also parameterize them. We can do it via static values, but what we usually want, especially in this case, because time in seconds is something that comes from the quiz data. So it could be different. We don't know if it is always 180. It could also be 60. And by the way, the test should tell me that, because there is a test which sets down the quiz to 2 seconds and waits for 2 seconds. And that one should fail right now. Yep, you see, the last test should run out of time after 2 seconds has failed, because now the SignalStore is running with a static time in seconds of 180. So how can we do that? How can we tell the SignalStore feature of with countdown that it should take the time in seconds from its parent store? Very easy. It is possible. First of all, we need to remove it here. We go into our with countdown. We also need to remove it from here. Just going to remove it somewhere else. Because in the SignalStore feature, we can also define requirements. So I can say, when I is with countdown, when I'm going to be used in another store, then I have an expectation, a requirement to that store. And the requirement is, and I can say here, state, so that it has to have certain state properties. Can also say I require a certain method or a certain computed. But in my case, I just say I require one particular state property, and there is a certain function available where I can define the type of it, and I say, time in seconds. This is what needs to be available, and if that's available, then I'm happy. Then I can be used. So this is now state time in seconds. Of course, here it's going to the compilation fails because I'm not accessing it here correctly. But I can say state time in seconds needs to be there. Store, sorry. Yeah. It's not there, yeah, because I also need to call the function. If it's a function, then it's there. Yeah, and we see the compilation works, and we have again a running quiz. So if I go back, the countdown is still working. The question, of course, now is it really type safe? So do I just say it here, or is there also somebody who checks it if there is really a time in seconds available? And yes, there is. So if I would say in my quiz store, it's not called time in seconds, it's called time in minutes, then I can save it, but we see already an error shows up, and the error now is a little bit complicated, but in the end, somewhere, it will tell me that there is something wrong with time in seconds or with time in minutes. So there is a real type check if we say we have these expectations for our consuming SignalStore. Yeah, by the way, yeah, I've already done this. Yeah, I think we are not done. So these are the extensions, very short, but I hope you got a glimpse of it and could in a way understand the power that they have. And there is one very powerful extension already available coming from NgRx Signals itself, and that's with entities. That's a set of methods, state, computeds, which very helps you when it comes to kind of managing those kind of CRUD applications. So it gives you those kind of add, update, delete, filter functions when you have entities in your state. And we're not going to cover this now, but look it up in the documentation. It's very well described here, and use it if you have a SignalStore which manages entities. Good. And by saying that, thanks for those of you who are still here. We have now time for the questions. Hello.
So there's a few more questions. There's a very long one if you want to take a look.
Yeah, I mean, I have time. I don't know.
Yeah, we have 5 more minutes, and there's not too many questions, just a big one.
Okay, good. Which one from Michael? This is probably getting ahead of your presentation, but I have to go to now. Hoping if you can answer the following question that it would help others want to describe SignalStore features. Earlier, Will's having its own section in the store and methods having their own spot, whatnot. My coworkers prefer separate files for store actions, or at least if there is a lot in the main storage. It is how the feature know the type of the state. Yeah, I guess Michael was exactly asking this kind of thing that I did at the end with the requirements. I know there is this type helper that can be imported, but example of type reference to the initial model, and I don't think that covers with computed values. It covers computed values as well. So with type, you can define the state, computed, and also the methods. Good. Then maybe just scroll a little bit to the top. Maybe there are some questions that I missed before. The toolkits session, local storage synchron. Yeah, that's also an extension coming from us.
Yeah.
Yeah, but you're right. Yeah, I think that were all questions. Yes.
Yeah, people are excited about it. People love your talk.
Oh, thanks. Yeah.
And they stayed up to the very end. So that's a good sign that it was really interesting and that they enjoy the demos and learn a lot of things. So yeah, thanks a lot for doing this. Thanks a lot for coming today and doing this presentation. The recording will be on YouTube very soon, possibly tomorrow or early next week. And yeah, everyone, thanks for coming today. Thanks for your feedback, your questions. And yeah, we'll do it again next month as we do. And have a great rest of your day, everyone. Thanks, Rainer, for your time and doing this session today.
Yeah, thanks for the opportunity. Thank you very much. And also thanks for all the people who had the patience to stay at the end.
Thank you. Bye.